Captions in English, please. So this is the 5th video on chapter 6, and we will learn to balance equations when there is an odd number of atoms versus an even number of atoms of one kind between the left and right side of an equation. So some reactions can be difficult to balance, but in many cases the use of the fraction method can help you balance it quicker. Let's go through an example. S8 plus O3 gives SO2. So O3 is ozone. So let's count the number of atoms on either side of the arrow. So on the left side we have 8 sulfur, on the right side 1. Oxygen, on the left we have 3, on the right we have 2 oxygens. So we see that neither of them are balanced. So let's balance the sulfur first and leave the oxygen for last. So we have 8 sulfur on the left, so we want to make it 8 on the right. So we will put a coefficient of 8 in front of SO2, and that would change the number of sulfur to 8 on the right. However, when we do this changes the number of oxygen as well. And now we have 8 times 2, so the coefficient 8 times the subscript 2, and that's going to be 16 oxygen on the right. So sulfur is balanced, but not oxygen. So now the sulfur atoms are balanced, which leaves the oxygen. Notice there is an odd number of oxygen on the right side, or sorry, on the left side versus an even number of oxygen on the right side. And so typically you always want to find the, make it the same number on both sides, and the larger number is the one you will choose. And here 16 would be the one you choose. However, it is not a multiple of 3. So to make it 16 on the left side, then how do we do? We want a total of 16 oxygen on the left side. So what fraction would you have to place in front of O3 to yield 16 oxygen? So the way to do this is that whatever coefficient you put in front of O3, so let's call it X, so X times O3, you want it to be equal to 16 oxygen. You can rewrite this by saying that 3x is 16, because the coefficient x will have to be multiplied by the subscript 3. So then it's 3x, and you want this to be 16. So then x is 16 over 3. So you place then this fraction in front of O3, and you see that when you take this coefficient and multiply it by the subscript of 3 that is on ozone, you get 16 oxygen on the left. However, a chemical reaction must have whole number ratios. So once the fraction is used, then it needs to be removed by multiplying the entire reaction by the same coefficient. And so here, because the fraction is over 3, to get rid of the fraction, you need to multiply everything by 3. So we will multiply all the compound and elements of that chemical equation by 3. So that's going to be 3s8 plus 16O3 on the left gives 3 times 8, 24SO2 on the right. And you can check that you have indeed, on the right side you have 24 sulfurs, and on the left you have 3 times 8, that's also 24 sulfurs. Oxygen, on the left you have 16 times 3, and that's 48, and 24 times 2, it's also 48 oxygens on the right. So this is balanced. So let's practice this by going through this first concept check. Again, as always, I want you to pause the video and practice this on your own before you watch the answer. So what do we have? Acetylene gas, C2H2, is often used by plumbers, welders, and glass blowers because it burns in oxygen with an intensely hot flame. The products of the combustion of acetylene are carbon dioxide and water vapor. So let's write the skeletal equation for this. So acetylene gas is, the formula is given, it's C2H2 gas. Is used and burns with oxygen. So oxygen is the oxygen from the air, and that's the elemental oxygen O2, and that's a gas. They burn to produce carbon dioxide and water. So carbon dioxide is CO2, carbon, and then 2 oxygens. Dioxide means 2 oxygens. And that's a gas because at those temperatures, that's a gas. And anyway, carbon dioxide at room temperature is a gas. And then water vapor, because water will be a vapor at those temperatures. So H2O in the gas phase. So that's our skeletal chemical equation. Let's count the number of atoms of each kind on both sides of the equation. So carbon, we have 2 carbon on the left, 1 carbon on the right. Hydrogens, we have 2 hydrogens on the left and 2 hydrogens on the right. Oxygens, we have 2 oxygens on the left and 2 oxygens in CO2 plus 1 oxygen in H2O. And so that's 2 plus 1, 3 oxygens on the right. So when you have these type of elements like carbon, hydrogen, and oxygen, you always want to start with carbon, then hydrogen, and finally oxygen. Always keep oxygen last, especially here because oxygen is, you know, in the reactant side, it's as the elemental oxygen O2. So that allows you to balance it more easily in the end. So carbon, we have 2 carbon on the left. We want 2 carbons on the right. And so we will use a coefficient of 2 in front of CO2 to make it 2 carbons on the right. Hydrogens, it's balanced now. Let's see, whenever you place a coefficient in front of CO2 here, it changes the carbons, but also the oxygens. So let's count the oxygens again on the right side. So we have 2 times 2, the coefficient times the subscript, and that's 4 oxygens from the 2 CO2 molecules plus 1 oxygen from water. So that's 5 oxygen on the right. So we want to balance the oxygens now. And we have 5 on the right, 2 on the left. 5 is not a multiple of 2. So let's make it 5 on the left. But for this, we will need a fraction of 5 over 2, because whatever we place in front of O2, because that's the molecule that has the oxygen, will have to be multiplied by 2, the subscript. So by having 5 over 2 times 2, it's going to be 5 oxygen on the left. So now we have 5 oxygen on the left. However, as we said, we cannot have coefficients that are fractions. So we need to get rid of that fraction. And so for this, we will need to multiply all the coefficients by 2 to get rid of the 5 over 2. So then it's going to be 2 C2H2 plus 5 oxygen, because 2 times 5 over 2 is 5, gives 2 times 2, 4 carbon dioxide and 2 molecules of water. And so this way it's balanced. You can see that you have the same number of carbons, 4 on both sides, same number of hydrogens, 2 times 2, 4 on both sides, and then 5 times 2, 10 oxygens on the left. And on the right side, we have 4 times 2 is 8, plus 2 times 1, so plus 2, that's 10. So we have 10 oxygens on the left and on the right. Oh, I had this prepared, and here it confirms that we have the same number of each atoms on both sides of the equation.